everyone, I'm Shaghig and I will be teaching you chemistry in WATAD. Today we are going to start with the first unit entitled Atoms and Chemical Bonding. That is the first unit of the program. We are going to start with lecture 1, which is basic introduction of the main concepts that you need to recall from elementary school or from grade 7 basically. In this lecture, we are going to discuss the difference between matter, pure substances, mixtures, elements, and compounds, which is something we always get confused in. The atomic structure, the difference between the atomic mass and the atomic number. And we're going to highlight the importance of knowing the first 20 elements of the periodic table in order. And we are going to recall how we can present atoms in nuclide presentation. We're going to start from a basic idea, which is trying to recall what do we mean by matter. And when we talk about matter, basically, we always define it as everything around us. But everything around us can be classified into two main groups, which can be pure substances or mixtures. When it comes to pure substances, it is subdivided into elements and compounds. By elements, we mean the fundamental substances that cannot be separated. That's the basic building block of everything. And the compounds are the combination of more than one elements. These elements can be of similar kind or of a different kind. When it comes to the mixtures, we are basically dividing mixtures into two, which are the homogeneous mixtures, where we cannot distinguish the differences between the components. And the main reason is because the components are dissolved. And for this reason, we can see only one phase. That is, like when you look at it, it's just one layer, you just see one thing. On the other hand, the heterogeneous mixtures are the ones that the components can be easily distinguished when you just say, oh, this is the component that is different than the other one in a particular mixture. For example, in a heterogeneous mixture can be considered a salad. For example, in the salad, you can simply identify all the components that is there. Simply you can say, oh, look at the tomatoes, or look at the cucumber, and so on and so forth. But when it comes to the homogeneous mixtures, when we are talking about, for example, salty water, you cannot just simply identify or look at the salt, because the salt is simply dissolved. But where do atoms stand in the whole story? All of these kinds of matter that we already discussed about, all are made of atoms. They are made up of atoms of similar types or different types. Here in this case, if we want to see the atoms that are in the element, we can see we have one type of atom in the element. And when it comes to the compound, it can be the combination of different atoms, and they make the molecules of the compound. These molecules can be made up of the atoms of similar type, as you see here, or they can be the molecules of different types of atoms, which are seen in this particular picture. When it comes to the mixtures, we can see that we have several types of molecules and elements mixed together, and they are making this mixture at a molecular level. Let's proceed. One important idea to consider is whether we have this misconception of the atoms or not. So basically, always we ask this question telling like, do you think we can see an atom or we can touch an atom? And this misconception arises because we always compare or confuse, let's say, atoms with the cells that we discuss in biology. Actually, we can see an atom, but this is by using a specific type of microscope, which is called the electron microscope. And if we observe the structure of the electron microscope, it's much complex than the microscope that we usually use in our school labs. So this is main idea. When it comes to the structure of the atom, this is the one proposed by Ernest Rutherford, and I'm sure in elementary school even you have seen this atomic structure. It basically has two parts, which are the nucleus and the electron cloud, and it has three basic subatomic particles, which are the neutron, protons, and the electrons. This doesn't mean that these are the only identified subatomic particles. Recently, scientists have identified some others like neutrinos and quarks. So those are outside the our context, but it's interesting to know that the neutrinos and quarks are other subatomic particles that may be considered. So basically now we are going to be discussing about the subatomic particles, which are basically protons, neutrons, and the electrons. It is important to know the symbols of each, which is for the proton is P plus. Later on we're going to see that this plus sign is because of its sign or the charge. The neutrons are N and a zero on the top, and electrons have a symbol E with a negative charge on the top. The focus here will be basically on the location of these subatomic particles. Mainly, we can see that the protons and the neutrons are the subatomic particles that are located in the nucleus, in the center of the atom, while the electrons are the ones that are found around the nucleus. And if we focus on the subatomic particles, we can see that, let's focus on the mass of each. So when it comes to the mass of the protons and the neutrons, we can see that we have 1.67 times 10 to the power minus 24. Actually, you don't need to memorize this number because most of the time it will be given for you as a given in any exercise. But what is interesting to note here that the mass of the electrons is basically 6 times less than this number. And here we can notify that the mass of the atom is actually focused in its nucleus, where we have the protons and the neutrons. And the mass of the electron is basically neglected. Because if we, mathematically speaking, if we talk about it, we can see that this particular number that we have means, mathematically speaking, it's like 0.26 So this number itself is a very, very small number. And imagine having the mass of the electrons being even less than this number, like by 6 times. And this is why we always say that the mass of the electrons is basically neglected. Now, let's focus on the charge of these subatomic particles, and starting by the protons. And I'm sure you remember from earlier that the protons are the ones that have a positive charge. And you see that it's positive 1.69 times to the power minus 19. Again, this number will be given to you, so you don't need to memorize. But I'm sure throughout the exercises, when you use this number a lot, you will be eventually remembering it without any given. We can see that we have of the same charge, but a negative one for the electrons. And when it comes to the neutrons, the charge is neglected because neutrons are the ones that don't have charge, which is another way of telling that they are neutral in charge. So all these atoms and the elements of the atoms are actually put and organized in something we call periodic table. I'm sure that you have seen the periodic table earlier. And all these elements that we have here are basically of each type, have each type of atom. And here in this case, it's very important to note that these elements, the atoms of the elements, are represented in a particular sequence, in a particular color and a group. We're going to talk about these later on in details, but I want you to know that the atoms of each element that we have is represented in the periodic table. And at this moment, at this stage, we have identified the scientists have identified around 118 elements. And maybe on the day that you're watching this video, this number will be wrong, because the scientists are simply discovering new atoms and elements with time. So as they discover the new atoms of the elements, they will be adding to this periodic table according to the, let's say, the properties and where it belongs to. And what is important for us as grade 9 students is to memorize in order the first 20 elements of the periodic table. Why memorizing the first 20 elements of the periodic table is important? Because the order in which the elements are put in the periodic table gives their proton number. So in this case, as hydrogen is put the first in the periodic table, it means that it has only one proton. Helium, being the second in the periodic table, has 2 protons. And knowing the proton numbers, these proton numbers will be eventually helpful for you to solve the exercises and the problems with more confidence. Of course, you need to also memorize the symbol of each, because most of the time you will be represented like the chemical symbols of all the matter that you are provided. As you see here, here is the hydrogen with 1 proton. Here is the helium with 2 protons, lithium, beryllium, and in this increasing order of the proton numbers, the elements are actually arranged and organized in the periodic table. So, it is very important and confusing from elementary school also, the difference between an atomic number and atomic mass. So basically, whenever we talk about atomic number with the symbol Z, we are actually telling the number of the protons. So if we say number of protons, Z, or atomic number, we mean all the same thing. And this is just showing a number. So for that reason, it doesn't have any unit. But when it comes to the atomic mass, which is represented as the symbol A, it's the average mass of a particular element. Later in the next lecture, we are going to actually talk about the mass and the average masses deeply when we talk about the difference between ions and isotopes. And as long as we are talking about a mass and not a number simply, so this gives a unit to this particular number, which is atomic mass unit, AMU. It's not like we can measure atoms in kilograms or grams, because we are talking about very, very tiny particles. So that's why we have this particular unit for them, which is atomic mass unit. So every time you are required to consider the calculation of the atomic mass, you need to consider the number of the protons and the number of the neutrons. As you remember, we said that the mass of the electrons is negligible as long as it's 6 times less than the protons and the neutrons. So we neglect. In the mass of the atom, we just consider the mass of the protons and the neutrons. And every time in the official exam, you need to use this formula to calculate the mass of the atom. You need to specify the legends. So here in this case, every time you're using this formula, please make sure that you write that A stands for atomic mass, Z stands for atomic number, and N stands for number of the neutrons. So please, every time you use this formula, make sure you mention the legend somewhere around. The order of the protons, or let's say the order of the elements from which you know the number of the protons, will help you to find the Z. So the order will help you to eventually make your calculations faster and more efficient. How to find the atomic mass? Here we're going to give a brief example. So we need to keep in mind that the atomic mass is simply the number of the protons added to the number of the neutrons. And let's have the example that for example, we're required to find the atomic mass of potassium, knowing that the N, which is the number of the neutrons, is 20. So here in this case, I need to use the formula, which is A is equal to number of the protons and number of the neutrons. And as I'm using this formula, I need to make sure that I write the legends at the side. And if I look at my givens, we have N, 20, which is the number of the neutrons. So we can consider that out of these two, I have the N given. But what about the number of the proton? Here comes the importance of the order of the, let's say, the elements that shows the number of the protons. So potassium being the 19th in the order, so we can consider that Z of potassium is 19. So here in this case, the calculation ends up to be 19, which is the Z based on the order of the potassium in the periodic table, and the number of the neutron, which is the 20. And when we sum them up, we end up to have 39 AMU, as long as we are talking about the atomic mass. The last idea that we are going to discuss for today will be another important aspect of representing atoms, which we call it nuclide representation. When we say nuclide representation, it ends up to have this, like, instead of the X, of course, you are going to put the symbol of the element, and this highlights the importance of learning the symbols of the elements in parallel to their order. And after putting the symbol, simply we should write the A, which is the atomic mass at the top, which is the number of the protons and the number of the neutrons. And at the end, we need to write the atomic number, which is the number of the protons, Z. As an example, we can take the nuclide representation of carbon atom. So in the middle, we put the symbol of the atom, which is in this case C. And on the top, we will be putting the atomic mass, which is 12 in case of the carbon. Later on, you're going to see that you will be calculating this, and you will be putting the answer of your calculation on the top. And at the bottom, you put the number of the protons of carbon, which is 6 in this point, in this example, because carbon is the 6th in the order of the elements that we have in the periodic table. So basically, this is the end of our first lecture. I will see you during our second lecture. Thank you so much.